Okay, let's take a look at this. What we're going to be solving today are two-step equations, or actually a single-step equation, but we're going to have to follow a couple different steps in order to do it. Okay, so if we take a look at this equation right here, okay, first of all we have two sides to it, okay, and the equal sign is what separates one side of the equation from the other. So what I'm going to make you do is divide this into two parts, okay, so I'm just putting little lines down on each side of my equal sign to show that there's two sides to this equation. Okay, this is one side, p minus 12. This is the other side, 20. Okay, now, one thing that you got to be aware of, the problems you're going to be doing for the next few days are going to be relatively easy as far as being able to see what the answer is. And that's really not the most important part. The most important part is solving these correctly, setting them up correctly, and showing work. You know, a lot of times you can look at these problems and see what the answer is, but we don't want to just go right to the answer. The concept of how to solve these is more important than the answer at this point. Okay, so first of all, we take a look at what we got, two sides to this equation. What we want to do is we want to isolate the variable. In other words, get the variable all by itself. So in order to do that, we have to get rid of minus 12. Okay, so what we do is the opposite operation of subtracting 12. So we add 12. Now, if I add 12 to this side of the equation, I have to go over to the other side and do the same thing. So I go over here and I also add 12. Okay, we're going to put a line underneath here and make it look just like a regular problem, like a math type problem. Now, the minus 12 and the plus 12 cancel one another out. So if we just work on this side of the equation, these two are opposite amounts, they cancel one another out. So we're left with just our variable over on this side, so I can bring that down. Here's my variable, the letter P. Okay, bring my equal sign down, and I'm keeping things lined up. Now, 20 plus 12 is going to give me my answer, and that is 32. Okay, now I can take my answer and put it up for the variable. 32 minus 12 does equal 20. I have solved this problem correctly by isolating the variable. And that's the process of doing it. That's how I want the problems to look. Showing work is extremely important. Let's look at another one. Here's one that's a little more difficult. It's set up just a little different. In this case, we have the variable on the right side instead of the left side like you saw in the previous problem. We're going to do the same thing. We're going to first of all divide our equation into two parts. This is one part, remember. This is the other part. The equal sign is the separator. That's what separates the two sides of the equation. Now remember our goal here. We want to get our variable all by itself. So that's the first thing you want to do. Find your variable and tell yourself you want to get your variable all by itself. So you got to get rid of everything that's with the variable or on the same side as the variable. So we need to get rid of the minus 16. Okay, so there's a process for doing that. And remember, whatever you do to one side of the equation, you have to do the exact thing to the other side of the equation. Even if it's the wrong thing, even if it's something that doesn't help in solving the problem, if you do it to both sides of the equation, you will not mess up the problem, okay? But obviously we want to do something that's going to be helpful to isolate the variable. So in this case here, we want to get rid of the minus 16. So we do the opposite operation, which is to add 16. So I add 16 on this side, and remember, whatever I did over here, I got to go over here and do the same thing. I have to add 16 over here. Okay? Now, my minus 16 and plus 16 are opposite operations that cancel one another out, so these are gone. Okay, here now we bring our variable straight down. Okay, and now if we solve this correctly, we will have the right answer. Now, negative 14 plus 16. Okay, the answer to that is positive 2. Now this is where a calculator can be used and to help to make sure that the numbers are crunched correctly. Okay, but the answer here is 2. Okay, now on one like this, very important that you check to make sure it really works. If you put 2 in for y, that's what you're saying, that 2 equals y or y equals 2. Okay, so if I put it in here, is 2 minus 16 negative 14? You can use the calculator to check that. Remember, we added our opposite when we did that, so we would have 2 plus negative 16 when you add your opposite. 2 plus negative 16 does equal negative 14, so this problem does check out. The nice thing about algebra, or solving algebraic problems like this, is when you get your answer, you can check to make sure you have the right answer. And the calculator is real helpful for doing that. And if you don't, you can go back and try to find your mistake and get it right. Okay, here's another one. Okay, this one has a mixed number, but still the same process that we used on the previous 2 problems. So the first thing I'm going to do is divide my equation into 2 parts. Okay, now obviously the first step here, talked about this in the previous 2 problems, find your variable. The variable is m. Okay, you want to get m all by itself, so you need to get rid of plus 1 3/8. Okay, the opposite operation, or to get you back to 0 from a positive 1 3/8, is to subtract 1 3/8. So that's what we're going to do. We're going to subtract 1 3/8. Whatever I do on this side, I got to go over here and do exactly the same thing. Subtract 1 3/8. Okay? Now, what makes this problem much more challenging is the fact that we got a mixed number involved now. So this is a little more challenging step here. These 2 cancel one another out. Okay, so we're left with just our variable m equals, I'm going to extend these lines a little further. Now I have to get this correct. 5 minus 1 3/8. Okay, your calculator can help you do that if you have a fraction key. Otherwise, in this case here, we have nothing to subtract 3/8 from. Okay, so we have to actually borrow here. We're going to make 5 4 and 8/8. Okay, I still have 5 here. 8/8 is 1, and my 4, 1 plus 4 is 5. So I haven't changed the value of this. I've just written it in a non-reduced form, 4 and 8/8. Okay? Now the reason I chose 8/8 is because I got a denominator of 8 right here. Okay, when you add and subtract mixed numbers, you have to have common denominators. So I chose 8/8, so I had a common denominator, so I didn't have to go through a process of getting a different denominator. Okay, so now I can go ahead and subtract here. So I end up with 5/8, and 1 from 4 is 3. So my answer is 3 and 5/8. Now, I can put 3 and 5/8 in right here, 3 and 5/8, and check it. Fairly easy. 3 plus 1 is 4, 5 and 3 is 8, so I get 4 and 8/8, exactly what I had changed that to. 4 and 8/8 is 5, so it does check out, so I'm feeling pretty good that I did the problem correctly. Okay? All right, here's another one involving fractions. Okay, once again, this time my variable is on the right side over here. That's okay. All right, so first step, find your variable, and you want to get your variable all by itself. So you need to get rid of minus 1/2 by doing the opposite operation to both sides. So we're going to add 1/2 to this side, go over here and add 1/2 to this side. Okay, now these cancel because they're opposites. So I have my variable all by itself, x, I bring it down, equals, and now I have to get this correct. I have negative 1 3/8 plus 1/2. We have a negative plus a positive. Now we have to think back to when we solved integers earlier in the school year. Okay, what is the rule when you have a negative plus a positive? Okay, if you have a negative plus a positive, you have to subtract and put the sign of the number with the larger absolute value. Or, in other words, the number that's furthest from 0 on a number line. Okay, the number that's furthest from 0 on the number line is negative 1 3/8. So I have to subtract, and my answer is going to be negative because this number is further from 0 on the number line. Okay, so I'm taking, I can subtract them just the way they are, or if you want to set them up on a separate spot or on another piece of paper, that would be fine. I'm going to do it right here. 1 3/8, I have to take 1/2 from it, okay? And my answer is going to be negative, okay, because the negative number is furthest from 0. I have to get a common denominator. In this case, it's 8 here. Okay, this I can leave alone because I'll have my common denominator. 4 times 2 is 8. 4 times 1 is 4. Okay, now when I go to subtract here, I cannot take 4 from 3. So I'm going to make this improper right here. Okay, I can borrow. I can actually borrow from here. When you borrow, you're making it improper. This is equal to 8 times 1 plus 3 is 11/8 here. Okay, so I can change 1 3/8 to 11/8. Now I can go ahead and subtract. I take 4 from 11, and that's 7, so I get 7/8. And I've already determined that it's negative 7/8. So my answer here is x is going to equal, and I got a mess here kind of, so I'm going to just write it over here. X is going to equal negative 7/8 for my answer. So certainly a fairly challenging problem. On this one now, you can take that negative 7/8 and put it in here, negative 7/8 minus 1/2. And that's a nice thing if you have the fraction key on the calculator, you can check it to make sure it really does come out to negative 1 3/8. And it does. So anyway, that's the setup on that one. Certainly a little bit more difficult. But the bottom line here is our goal today is to isolate our variable, get it all by itself. Okay, so hopefully this will help for you to do that.